So we got calculus, unit 7, day 63, part 2. If the axis of rotation is the x-axis or is parallel to the x-axis, the integrand needs to be in terms of x, and the limits of integration need to be the x values of the points of intersection of the curves that form the region being rotated. So it's just, we want it in terms of y equals. Okay, so this example is going to be kind of like what we just talked about, and then later we'll do an example where I need everything as x equals, and we need to be rotating around a vertical line, either the y-axis or some line, x equals something, and then we'll need it x equals, everything will need to be in terms of y, and then dy. But so this is always going to be in terms of x and dx. Okay, so here are my two functions, y equals x squared and y equals x plus 2. Find the volume of the solid formed when the region is rotated about the x-axis. Well, the nice thing is, here's my straight line, and here is my, and again, this is y equals x plus 2. That's going to be, because we're going about the x-axis, that's going to be our outside function, the outer function, because it's further away, and the parabola is going to be my inside function, because that's always closer to the x rotation. Okay, and we're trying to find the volume of this shape as I rotate around the x-axis. Alright, so we're just going to follow our function, so let's write that now. Okay, and we're thinking as I rotate it, it's just going to be an infinite number of circles created. And again, what's the area of a circle? Pi r squared. We're talking volume, but if we think of a cylinder, it's base area times the height. So the base area is the circle, and that's going to be pi r squared times the height, which is a bunch of different, if I look at my shape right here, if I'm looking at it from this way, again, I have all these circles, and the distance between them, the delta x, is our dx at the end. So we need to think of just pi r squared. There's our pi, it's a constant, we bring it out. The radius is going to depend on the outer function, which was x plus 2. And again, we had to subtract what we're rotating about. So I don't need to put the minus 0, I'm just showing that's what it is. And then our inner function is the parabola, x squared, again, minus 0, and then dx. Okay, so I first want to simplify this. Okay, and when I first wrote that, I just added in, I forgot to write the squared right here, because this is the outer radius, this is the inner radius, and they're both being squared. I didn't have that squared right there, and I also didn't talk about where I got the negative 1 to 2. So it's this region was given from negative 1 to 2, and you may not always be given those values, so you might have to find the point of intersection first. So that's just an added step, which again they gave us here by these points. Okay, so there's the negative 1 to 2. All right, and now all I do is let's use the fundamental theorem of calculus. Let's take the antiderivative and let's evaluate from negative 1 to 2. Okay, so this becomes x cubed over 3. It's going 4x squared over 2, which is just 2x squared, plus 4x minus x to the fifth over 5. I'm going to evaluate from negative 1 to 2, so I'm going to put 2 into all of these, get those values, and then we're going to subtract when I put negative 1 into all these. Alright, so let's go through and do that. So I just went through, put 2 in there, and the first 2 I changed to over 3, so those could be like denominators. And now I'm going to go through and simplify this. And if we were doing this on the AP Calc exam, I could leave my answer right there. So, because I could do this with a 4-function calculator. Well, let's go see what we get. And we get 72 over 5 pi. Alright, so now we have to do the exact same thing, except if you look below, we have y equals 4 as our axis symmetry, and y equals negative 2. So it may change what the outer function is and what the inner function is. And let's take a look at that now. So y equals 4, I put the dotted line. Now my outer function becomes the parabola, and the inner function is always the straight line. So that will impact it. And let's do, what was that? Y equals negative 2. And this will be exactly the same. The outer function is the line, and the inner function is the parabola. So the last one will be very similar to what we had for the x-axis. And I should probably label these two. So this was the line y equals 4. And down here, this is the line y equals -2. So even though it's horizontal, the x-axis is y equals 0. So we just have to pay attention to that. All right, so let's start doing these. Okay, so our outer function is for y equals 4. So again, we're always thinking pi r squared because they're circles. We're rotating around a horizontal line. So the horizontal axis symmetry. So this is x squared. The parabola is the furthest one away. So it's x squared minus 4, all squared, because that is the new radius, and that's squared, minus the inner function, x plus 2 minus 4, which that is going to become just x minus 2 whole squared. But I want to show you what it looks like in that first step. Okay, so then we'll simplify that. I'm going to do all that work in part 3. And over here, it's the same outer function. It's the line, so it's x plus 2 minus the -2. So that's really the same as x plus 4 all squared. And then this is x squared minus the -2, which is just x squared plus 2. And again, that's all going to be squared. Okay, so we'll show out that work for part 3.